Hey guys, today we are going to do the second part of this section. So we're going to mostly focus on measures of variation and how we can determine population versus sample. So just a quick review of yesterday. We learned about measure of central tendency, which included mean, median, and mode. And you have to choose a situation where would it be most appropriate to use mean or median or mode. And so I hope you remember that. And so today we're going to go to measure of variation. So it just means how spread out or scattered your data is. So I think if you remember the example I gave you from yesterday, the example I gave you was everyone getting a 0 on the test and then one person getting 100. So this one, because of the outlier, it looks like your data is spread out, but if you get rid of the outlier of 100, it's really not that spread out. Everyone got the same score. So this is a very small variation, right? Range, however, is very big because of the presence of outlier. So yesterday we talked about something called resistant measurement. Resistant statistics, which was like a median. So median is resistant, and the measure of variation that goes with median is something called IQR. IQR stands for interquartile range. Interquartile range. Okay, so it's found by quartile 3 minus quartile 1, but we're going to look into that a little bit more today. The two measurements that are not resistant are, well, 3: variance, standard deviation, and range. Because all of these 3 measurements use individual data value instead of like the position of the value, which is what median is. It's a position, right? And so they are not resistant. So you only use them when your data is symmetric and unimodal. Okay. So the relationship with variance and standard deviation is important because variance is square of standard deviation. And this little guy, we read it as sigma. So this is the small case of sigma. Another sigma that you know is this one, which represents sum in mathematics. That's a capital sigma, and this one is a small sigma. So you write it like this. It's a little O with a hat. And so sigma represents standard deviation. So what is the standard deviation? It's basically kind of like the distance between the data from the mean. So standard deviation is based on mean, and variation, so variance is a square of standard deviation. And I know this formula looks very complicated, but you'll never have to really find the value using the formula like by hand. I think it's kind of silly because statistics is mostly done using software anyways. So we're going to just learn about how to find this on your calculator. Okay. So let's look at, and the range is a single value. I know you guys are used to a range of like, it's from 5 to 10. That's not range in statistics. In statistics, range is a single value. So if your minimum is 5, so range is maximum minus minimum, right? If your minimum is 5 and maximum is 10, then the range would be just 5. Okay? So that's what range is in statistics. So let's go to some example problems. All right. Give me a second. I'm going to type all this data in the calculator and then I'll be back. All right, so I have typed all the values now. So if you remember from yesterday, what we do is that we do we're gonna go to stat, calc, 1 bar stats, and then I'm gonna start with list 2, which is number 3 for me. Okay, so we're gonna do list 2 and then enter, enter, enter. So yesterday we learned that the X bar represents mean. So let me rewrite that. So this is number 3. And there is a sigma sign right here, right? But we are never going to use this one because even though your textbook doesn't distinguish between population standard deviation versus sample standard deviation, if you go to a more advanced statistics, we're going to stick with S of x. So this is a standard deviation for sample. And I think it'll be very confusing trying to explain why those two standard deviations are different. So just know that you're going to stick with S of x and not sigma of x. N just represents how many data there were. And then we're going to go down to see our something called 5-number summary. So 5-number summary has 5 parts. Minimum, Q1, so it's a quartile one. I'm going to explain what that is. Median, Q3, and maximum. Minimum is 11, maximum is 65. So range is 65 minus 11. So the range is 54. So range of this data right here is 54. Q3 is 52. Median is 23.5. And we talked about that at length yesterday compared to like mean. Why is it so different? What does that mean when it's so different? And also, so we're going to just focus on variation today. So IQR, like I said, is Q3 minus Q1. And those are that two values, 52 minus 17. So let's do that, 52 minus 17. So my IQR is 35. So quartile, we're going to look at quartile. So to look at quartile, we actually should look at box plot. Box plot, I think I maybe went into it a little bit. So the dot one, right? So when you do zoom line, so this is a box plot. So box plot is really, there are 4 parts, right? And those 4 parts represent 25% of your data. So it doesn't matter how long your line is or short your line is, the number of data that they indicate are all equal. So this one has like 2 data, 2 data point, 2 data point, and 2 data point, and so forth. Because there are 10, and then like you're trying to divide it by like 4, obviously it doesn't really work. Like you have to have like half of that and things like that. And so let me use a trace. So minimum, so this is actually number 1. Sorry, this is not the number 3. I need to, give me a second. So this is actually for number 1. So there are 5 datas only, and then we are dividing into 4 sections, right? So you can see minimum is 758, and then 767, which is not part of our number, right? And quartile 1 doesn't have to be like quartile 1, median, and quartile 3 don't have to be your actual data. It's just like an indicator where your 25% of the data belongs to. So think of it as quartile 1 as a point that you have a 25% of your data. Quartile 2, which is also median, so up to median you have a 50% of your data, and quartile 3 you have a 75% of the data, and then a maximum that has 100% of your data. So quartile 1, how you find it by hand is you find median of the minimum point and the median. So quartile 1 is a median of minimum and median. Quartile 3 is a median of median and maximum. That makes sense. So so the box itself is IQR. So if you do the Q3, which is right here, and minus Q1, then that gives you a range, the interquartile range. So inter is like in between, right? In between quartile range. That's what IQR is, okay? So this one is quite large, quite long, but that's for number 1. So if you want to see box plot for number 3, we can change that to L2, because I think my number 3 is in L2. So you can see this IQR is also very large because the range was only 54, but IQR is 35, so that's more than half, right? So it's a very long IQR, which tells me, what it tells me is that the fact that it took a really long time to get capture 25% of your data, it was more spread out at the end of my tail than the beginning. So in the beginning, there were a lot of data together, so that's why these are short. And at the end, the data probably was like spread out so much that it took a really long time to get to the 25% of your data. So that's why it looks like that. All right. So I hope that makes sense, IQR and standard deviation. So because, like, the same reason you chose mean and median. So in this case, I'll choose median because I suspect skewedness. So when you describe the distribution with median, you want to also put IQR with it. Because when you describe a distribution, you always give a measure of center and measure of variation. So when you choose mean, you're going to describe it with standard deviation. When you choose median, you're going to describe it with interquartile range. All right, let's go to population versus sample. So population is everything that I was interested in. So like, it will contain a word like all, every, or something like that. That indicates that it contains every single person that I'm interested in. It doesn't have to be a person, obviously. Sample is a portion. It's a fraction of what you're interested in. So number 2, let's look at number 5. Jerry's math club wants to compare their SAT scores to the scores of all students who took this SAT. So this would be population because it says all students, right? So that word all kind of gives it out that this is a population. So I'm going to just write P. Number 6, the tennis team wants to compare their first serve percentage with each other. This one also seems to be population because my interest is tennis team and I'm going to compare everything with each other. So like, you have to gather all the information from them and then from us. So that's population. There is no sample. It says 7, Jennifer conducts an online survey on political opinions. So this one is a little bit more vague because it doesn't tell me what Jennifer is interested in knowing, but it is a sample because there is no way Jennifer can get information from every single person in this world, right? So it will be a sample. It will be a poor sample with lots of bias because only people who have a very strong opinion will go and vote or tell their opinion, but it is still a sample. 8, Veronica compares the student-teacher ratio of all of the schools in her country. That would be very hard, but it's all, so it's also population. That's it. I hope the population versus sample makes sense. So the key is to look for the word like all or like an impression that, okay, what am I interested in? And do I actually collect data from everyone that I'm interested in or only the fraction of the people? That's all it is. Sorry, my nose is getting itchy. And that's it for today. I hope today's lesson was also simple enough. Again, that if you know how to use a calculator, you do not have to memorize this formula or do it by hand. You only need to remember that variance is a square of a standard deviation and how to find IQR, how to find range, and when is IQR used, when is standard deviation used. Standard deviation goes with the mean and the IQR goes with the median. And know that box plot is 25% of data. So it doesn't matter how long or how short something is, it still contains the same number of data as the next portion. Okay? And I will see you tomorrow.